Welcome to the first video of Chapter 1. This is Section 1.1, Identify Points, Lines, and Planes. At this point, you should have out your note packet, and you should have out a pencil so that you can follow along with me. At the beginning of each video, I will tell you if you need a calculator or not. For this video, you don't need a calculator. At the beginning of each set of notes, you're going to see a set of objectives. That's everything that's covered in the video. So today's video is going to cover 3 topics. We're going to name geometric figures, we're going to sketch geometric figures, and we're going to determine if a point is on a given line. At the beginning of each chapter, generally we're going to start out with vocabulary. Chapter 1 is no different. You're going to notice on your note sheet the entire first page is vocab. So let's jump right in. For each term, we're going to write down the definition, and then we're going to find some examples in that figure to the right, the yellow figure with the points and lines. So, first definition is a point. You probably know what a point is, but a point is just a dot. So at the right, we have this point X right here. We have this point that's not marked. We have this point G. We have this point N, etc. So, notation for a point. The notation for a point is just one capital letter. So for point X, I'm going to put an X. For point G, I'm going to put a G. For point M, I'm going to put an M. So the notation is just a capital letter. Okay, some people are tempted to put a point in front. So, well, it's point X or it's point G. This is wrong. Don't do that. Don't put a point in front. It's understood in math that if you put a capital letter, you're talking about a point. So a line, then, is a set of points continuing in 2 directions without end. So in that figure to the right, you can see one line. So this line right here. So it has a whole bunch of points here that you can't see, but they just continue in 2 directions. They continue up and they continue down. So notation for a line. There's actually 2 different notations. The first one is that you pick 2 points on that line. So in the line in blue that I highlighted, M and G are on that line. So I would write MG with a little line over the top. Well, G and N are also on that same line, so that same line I could write as GN. Or I could write it as MN. So you just pick 2 points on that line. That's the common notation. Another notation that you could see, but it's not as common, is 1 lowercase letter. So our line doesn't have a lowercase letter, so let's give it a lowercase a. So we could also call that line A. And you're going to write out the word line. You're not going to put any notation. Okay, next term is a plane. A plane is like a flat piece of paper that continues without end. So a plane would be as if the piece of paper that you're writing on just continued in all directions. To the right, that yellow box, that's a plane. So because we're drawing in 2 dimensions, you can't see that it's continuing in all directions, but you have to imagine that it is. Notation for a plane. Again, there's 2 different notations. The first one is that you choose 3 points that are on that plane. Okay, so point X is on that plane. This point right here is on the plane. It doesn't have a letter, so let's call it point B. And let's put a 3rd point on the plane. Let's maybe call it point Y. So then we could name this plane X, Y, B. or x be y, or y be x, doesn't matter the order. Same thing for a line, the order doesn't matter. So that's the common notation that you're going to see a lot of times. Second way to denote a plane is by a fancy letter. So if you're going to notice on the plane, we have this fancy R at the right. So we also could call this plane R. Again, I really want you to use the first notation, the 3 points, but you may see that fancy letter also. Okay, next definition is a line segment. A line segment is a portion of a line with definite endpoints. So it has a defined beginning and end. So we have our line from before in blue. A line segment, for example, would be the part that goes from M to G. So it's a part of the line, it has a start and it has an end. There's only one notation for a line segment. So that segment in green, I would call it MG and put a segment over the top. Now notice, a segment has a segment over the top, a line has a line over the top. So when you denote a line, the symbol over the top should have arrows at the end to show you that it's a line, that it continues. Whereas a segment should not have arrows at the end. Now what's important about denoting a segment is that you have to choose the 2 endpoints. So for a line, you can choose any 2 points on that line, as long as they're on the line. For a segment, it has to be the 2 endpoints. So looking at a different segment, how about this one that starts at G and it goes towards N? So this one in pink. Now if I'm denoting that, it starts at G, it goes towards N, and it's a segment. B is on that segment, but it's not an endpoint. Okay, moving on. A ray is a portion of a line with only one endpoint. So drawing it off to the side, it's going to have an endpoint, and then it's going to continue in one direction. So we'll continue in one direction, but not both. So notation for a ray. I'm going to erase these markings that we had before, or not. Okay. I'm going to highlight it in black. So if we look at the ray that starts at G and continues in this direction. Okay, so the notation, I start at G and I continue towards B. Now you're going to put a ray over the top. I start at G and I continue towards B. So you have to include the endpoint. So that G is the endpoint. And then another point that's on the line. Just any other point. Or on the ray, that is. So let's look at a different ray. Let's draw one in, actually. Let's look at this ray right here. So to denote that ray, G is my endpoint, X is on the ray. Now G is the endpoint, so I want to make sure that it looks like the endpoint. So I start at G, continue towards X. That is not the same thing as this. So that's what you need to know. Those are not the same. On the left, I start at G, continue towards X. On the right, I start at X and I continue towards G. So it's very important the order for a ray. Line, the order doesn't matter. A plane, the order doesn't matter. A segment, the order doesn't matter. A ray, the order does matter. You have to make sure you use the endpoint and that that's on the side that doesn't have the arrows. If you're confused, please make sure you ask me in class about that one. Okay, a few more words. The Next one is collinear. So co, you should know, is together. Linear, you should be able to figure out, is line. So collinear is points on the same line. Okay, so any 2 points are collinear. Any 2 points can form some line. So we're really interested in like 3 points that are on the same line. Well, looking at our figure, an example would be all the points that are on that one line. So M is on that line, G is on that line, B is on that line, and N is on that line. So we would say points M, G, B, and N are all collinear. They fall on the same line. X is not collinear with these 4. P is not collinear with these 4. Those points are not on the same line. Okay, coplanar, you should probably be able to figure out co, together, planar, plane. So coplanar is going to be points on the same plane. Okay, and that one you'll just be able to look at the figure and tell me, yes, the points are on the same plane, or no, they're not. What's important about the coplanar is just a special exception is any 3 points are coplanar. Okay, so I told you to name a plane you need 3 points. That's because any 3 points will form a plane. So for example, if we look at our figure, if we're talking about points X, P, and G. X, P, and G, do they all lie on the yellow plane? Well, no, that should be obvious. But they are 3 points, so there is some plane that they all lie on. So X, G, and P would be coplanar. Okay, we got a few more definitions and then some examples. So opposite rays are rays that share the same endpoint. And they continue in opposite directions. Okay, so let's draw one ray. Has an endpoint and continues in one direction. So let's call this ray AB. Starts at A, continues towards B. Okay, an opposite ray to that is going to have the same endpoint A, but go in the other direction. So this one's going to start at A, continue towards C. So those would be opposite rays. You're going to notice opposite rays form a line. So I'm going to add that to the definition. So opposite rays form a line. So in this case, they would form line CB. Or I could call that BC, I could call it AB, I could call it AC. Just pick 2 points on the line. And then lastly is intersection. So intersection is going to be all the points that 2 figures have in common. So for example, if we're talking about this line right here and this line right here, they share this point. So that point would be the intersection. For another example, if I'm talking about this line and this segment, they overlap at the segment. So the segment would be the intersection. So you'll be doing some examples like that in class where I show you 2 figures and you're just going to have to tell me what they have in common. So that's all the definitions. If you have any questions, please make sure you ask me in class tomorrow. Now, flip the page. Okay, so example number 1, it says use the diagram provided to answer the following questions. Sometimes I'm going to do some examples with you, sometimes I'm not. I'm going to leave it up to you. So, this one I'm going to do with you. It says give 2 other names for line PQ. So line PQ, that's this line right here. So I told you one way to name a line is with 2 points. So that would be PQ. I could also write it the reverse direction. So I could write QP. Got to make sure you put a line over the top though. I told you the other way is with a lowercase letter. And you're going to see we have that lowercase n. So we could also write line N. So line PQ, line QP, or line N, those are all names for the same line. Okay, B, give 2 other names for plane R. So plane R, that's this one right here. So I told you the way to name a plane is with 3 points. So we're going to call this plane. Okay, and then the thing I did not tell you is the points cannot be on the same line. So I cannot say plane SPT. Those points are on the same line. I can say plane SPV though. Those are not on the same line. Or I could say plane STV. So just 3 points. Right now, I would like you to pause the video and do C and D on your own, please. Okay, at this point, you should have paused the video and done C and D on your own. When you come back now, I'm going to go over it with you. So 3 points that are collinear, 3 points on the same line, well, we would say S, P, and T are all collinear. They all fall on the same line. Remember, don't put a dot in front. 4 points that are coplanar, so 4 points on the same plane. That would be S, P, T, and V. Those all lie on plane R. Hopefully that went well for you. If you made a mistake, that's okay. We're going to move on to examples 2 and 3. These we're going to do together, and then you're going to have one on your own. So it says in example number 2, is the point 3, 19 on the line y equals 4x plus 7? You should have seen this in Algebra 1, but we just want to substitute that point in. So I have the line y equals 4x plus 7. Hopefully we remember in an ordered pair, the first number is x, the second number is y. So 19 is going to go in for y, 3 is going to go in for x. Okay. I'm not sure if these are equal yet, so I'm going to put a little question mark over the top. That's what I'm trying to see. Are they equal? 4 times 3 is 12. Okay, so 19, is that equal to 12 plus 7? Well, yes, I have 19 equals 19. Okay, what does that tell us? So the question was, is the point on the line? Well, I found the left side and the right side were equal, so we would say, yes, 3, 19 is on the line y equals 4x plus 7. So that's our final answer, and I want a sentence like that, so I know what your answer is. If the point was not on the line, the left side and the right side of the equation would not be equal. We would have 19 equals 12, or 19 equals 7, or something that was not equal to 19. Okay, last example that we're going to do together. It says graph on a number line. Tell whether the graph is a segment, ray, rays, point, or a line. Okay, so we have x is greater than or equal to 7. So we're going to need a number line. It definitely has to have 7 on it. I'm going to have 8, 9, 6, 5. Okay, equal to 7. So I'm going to have a closed circle. And then it's also greater, so everything to the right. So this would be my graph. And this graph is going to be a ray. So hopefully you remember that from algebra also. Okay, we've come to the end of our video. At the end of the video, I'm always going to return to the objectives. So, we named geometric figures. That was the first page where we wrote down all those definitions. Sketch geometric figures. We didn't do that in the video, but you're going to do that tomorrow in class. And then determining if a point is on a line, that's what we just did when we substituted the point back in. Besides looking at the objectives, I'm going to give you some to try on your own. So you have those 2 problems to the right. When you come to class tomorrow, I'm going to make sure you have all the notes done and these 2 examples done. If you don't have the examples done, you will not get credit for the notes. It's okay if you get the examples wrong, but I at least need you to put forth an effort. I at least need you to try. So, good luck. Please write down any questions that you have for me and we'll go over them tomorrow. See you tomorrow.